Brian Young. Today we're doing Module 26112, Electrical Test Equipment. Let's get started. Module 26112, Electrical Test Equipment. Successful completion of this module prepares you to do the following. Identify different types and kinds of electrical test equipment. Identify the application of a voltmeter, an ohmmeter, a clamp-on meter, and other types of meters. Identify meter category ratings and safety requirements. Describe how to select a meter with the correct category rating for an application. Identify electrical test equipment safety hazards. And there are performance tasks. Your instructor is going to want you to measure voltage in the classroom from line to neutral and line to ground, and use an ohm meter to measure the value of various resistors. When you pick equipment for a task, it's important to consider what you're measuring, the level of accuracy you need, and the safety requirements. This module is about different types of electrical test equipment and how they are used. It also describes how to use meters safely and what category rating means. 1.0.0 Identifying meters. Electrical test equipment, instrument, and meters are typically used to identify problems with electronic circuits and equipment or verify that circuits and components are working correctly. Basically, we were learning before about voltage, current, resistance. We have meters to measure the amounts of all of those. So even power, we have watt meters. To succeed in the electrical field, you must know how to identify the types of meters and when they're used. This section teaches you how to pick the right equipment for a job and identify potential hazards present when working with test equipment. They go on to talk about D'Arsonval, and he came up with the D'Arsonval movement. This meter used a non-moving permanent magnet and a coil that moved to measure current flow. First galvanometer was very accurate but could measure only very small currents. Over the following years, many improvements were made to extend the range of the meter and increased its ruggedness. So here's a highlight. It says, using a moving coil movement, the D'Arsonval meter movement, figure 1. That's a highlight. So they might ask you what kind of a movement uses a moving coil, and the answer is D'Arsonval. And there's another highlight. It says, as an application of the electromagnetic principle and is still the basis for analog meters today. So basically, D'Arsonval used a permanent magnet and a coil, and as you put voltage or current through that coil, it makes a magnetic field, and depending on the strength of the magnetic field, the needle is going to deflect a certain amount. It's on a spring, so the spring gives it a very linear movement, meaning it moves twice as far when 20 volts is being read than it does when 10 volts is being read. So it's very linear. Here's an analog meter using that D'Arsonval principle. You can see the scale here, volts, AC or DC, 0, 20, 40, 60, 80, 100. And then there will be a selector switch that you can change it to 2, 4, 6, 8, 10 volts. This is volts or amps or milliamps, AC or DC, and then the volts down here is 0, 10, 20, and 30. So basically you have the permanent magnet located behind the plates, and then there's a moving coil. The function of the selector switch says what you're going to be measuring, either amps or volts, or DC volts or amps. And the range selector switch, so 10 volts, 30 volts, 100 volts, 300 volts. This changes resistors that are either in series or parallel, depending on the function, with the meter movement. If it's voltage, they're in series with it. so they make a voltage divider network, and if it's current, they're in parallel with it, so they will take the bulk of the current, leaving just a small amount going through the meter movement, and then you use a multiplier to read the phase. Okay, it says a moving coil meter movement operates on the electromagnetic principle. In its simplest form, the moving coil meter uses a coil of very fine wire wound on a light aluminum frame. A permanent magnet surrounds the coil. The aluminum frame is mounted on pivots to allow itself and the coil to rotate freely between the poles of the permanent magnet. When current flows through the coil, it becomes magnetized, and the polarity of the coil is repelled by the field of the permanent magnet. This causes the coil frame to overcome the force of a spring and rotate on a pivot. The distance it rotates is determined by the amount of current that flows through the coil. By attaching a pointer to the coil frame and adding a calibrated scale, the amount of current flowing through the meter can be measured. That basically, in a nutshell, is the D'Arson ball movement. Not a lot of people use them anymore. Those are analog. You see them in equipment. Sometimes you'll have a permanently installed ammeter on a piece of equipment, and it might use that D'Arson ball movement. It might have a moving dial or a moving needle going across a scale. But most handheld meters now are digital. They don't use that principle. Today, most meters use solid-state digital components because they're easier to read than mechanical meters and have no meter movement or moving parts. So, analog meters may also be better for. It says some of today's digital meters display a bar graph below the numbers to replicate the movement and functions of the older style analog needle. Analog meters may also be better for testing systems that work at less than 50 volts, checking transformer polarity, or taking quick measurements. Phantom readings. Sometimes digital meters can show a very low reading even though there's no current flowing through them. These are called phantom or ghost readings. They happen because the meter is picking up signals from other energized electrical equipment nearby. Some digital meters have a low impedance function that will help confirm the reading is accurate or is a ghost reading. 1.1.0 voltmeter. So this is testing for voltage. Remember, that's a difference of potential. A voltmeter is used to measure the exact voltage. That's a highlight. Voltage is also known as potential difference or electromotive force. The voltmeter leads are connected in parallel with the circuit or component that's being measured. Analog voltmeter uses the basic D'Arson ball meter movement. It has a specially arranged resistors for measuring different voltages. A digital meter has a chip that changes the analog signal into numbers on pictures or pictures on a screen. Here's a highlight. It says, if you use a voltmeter that's not auto-ranging, always start with the highest voltage rating. So if you're not sure what the voltage is, if it has a 1,000-volt range, start on the 1,000-volt range. And then if the reading is very small, you can change the setting to 200 volts to see more accurately. Then work down until the meter reads somewhere between 1/2 and 3/4 of the scale. This will give you a better reading and keep the meter from breaking. 1.1.1 voltage tester. When you need to know the exact voltage, you must use a voltmeter. However, electricians often are concerned with identifying whether a voltage is present and or, if so, the general range of the voltage. In other words, is it energized? And is it 120, 240, 480? In these cases, you can use a voltage tester to ensure that voltage is available when needed and that the circuit or equipment has been de-energized when necessary. So here's a voltage tester. It's not a voltage meter because it's giving you a generic or very generalized 120, 208, 240, 277, 480. It doesn't tell you it's 121.7. It says, for example, if you have a power tool that isn't working, you can use a voltmeter for troubleshooting, a volt tester. Voltage tester can show that you have power The power is available, which means the problem is with the drill itself. If you need to work on a circuit, you can use the voltage tester to confirm that the power has been shut off and that the circuit is de-energized. It's safe to work on the circuit only after verifying it is de-energized. So advanced voltage testers often offer additional features such as a digital readout, GFCI test capability, and even the ability to switch between use as a contact and non-contact detector. So contact detectors, you have two probes. Non-contact won't tell you if the voltage is 120 or 240. It'll just tell you that there is a voltage present. This LED will light up telling you that yes, there is the presence of a voltage, but it won't tell you what that voltage is. When you're using the leads, it's a voltage tester. It can tell you generally the range of the voltage in DC or AC. Notice this squiggle line looks like a sine wave. This is AC, alternating current or voltage. This line has a straight line above it, and that means it's DC, okay, steady state. Make sure you check your voltage tester every time before you use it. It's important to verify that it is in good condition and working correctly. Inspect the outside of the meter to verify the leads aren't cracked or frayed. Faulty leads are a safety hazard and must be replaced. To confirm the voltage tester is operating correctly, connect the probes to a known energized source, such as an outlet. This is a non-contact voltage detector. What it's actually looking for is an alternating magnetic field. So when it finds an alternating magnetic field, it'll chirp, it'll go off, this light will light up. So it's not a voltage tester or a voltage meter, it's a voltage indicator. It indicates that there is the presence of a live voltage. You can use a non-contact or proximity voltage detector to find out whether voltage is present in a circuit. A voltage detector indicates when there's a voltage but does not detect specific voltages like a voltage tester. Caution, be careful when putting tester probes on a voltage source. Some voltage testers are made to take quick readings. They can be damaged if they stay on the voltage for too long. Here's a live test. You want to make sure that your meter's working. Then you want to check a circuit to see if it's dead. And then after you check that circuit, you also must check your meter one more time to make sure it's working correctly. Before working on any conductor or circuit part, it's important to assume that all the circuits are energized until you confirm they're not. Here's the highlight. You can determine this by performing a live test. One of the first steps in performing a live test involves verifying that the meter is operating properly prior to using it on an actual circuit. To do this, a proving unit is used to supply a known electric voltage. To operate a proving unit, the leads of the meter to be tested are connected to the positive and negative terminals of the proving unit. Then the meter is checked to make sure it displays the exact expected value. You don't have to use a proving unit. You can just use a known live outlet, such as a receptacle. Put your prongs in there and see if it reads 120 volts. But know the term proving unit. To do this, a proving unit is used. That's a highlight. Know the term proving unit for testing your meter. Verify the circuit's properly tagged and locked out. Confirm the test instrument is working properly by testing it on an energized item that has a known voltage. You can use a proving unit to perform this task. Don the appropriate PPE. Now using the test instrument, check the circuit you think is dead. The voltage should be 0. Test line to line, line to neutral, line to ground. Verify the test instrument is working properly again by using it one more time on a known energized source that has a voltage you know. So that's the live. This is the second live. Under all circumstances, always test before touching any electrical conductor, even if it's been locked out and proven to be previously de-energized. That's very good advice. because high voltage lines, 480 and higher, will have a residual, almost a capacitive effect, especially if they're like 2300 volts or 4160 volts. Those wires will build up a static charge. So you de-energize it, you find that it is de-energized, you lock it out, you tag it out, you can still receive quite a significant shock from those cables just from the residual stored capacitive effect around the dielectric or the semiconductor of that cable. You need to take a shorting probe that's grounded on one end and touch that cable to bleed off any static that might be left behind. So make sure that you do that. You won't be working on high voltage early in your career. You're going to be a journeyman electrician or very close to it before they have you working on anything higher than 240 or 480. 1.2.0 ohm meter. Remember, ohm is for measuring resistance. An ohm meter measures resistance of a circuit or a component. That should be a highlight. It can also be used to locate open circuits or shorted circuits. An ohm meter consists of a DC current meter movement, a low voltage DC power source. That's important. It has its own power source, usually a battery, and current limiting resistors, all connected in series with the meter as shown in the schematic in figure 6. So it has its own power source. Okay, that's good to know. That's how the ohm meter works. Using this power source, it puts a very small current through a resistance, and it uses Ohm's law, and it says at the known voltage and current, this is how much resistance we're coming into contact with. Before you measure the resistance of an unfamiliar resistor with an electrical circuit, connect the ohm meter leads together and adjust the meter to read 0. This removes any resistance remaining in the leads. This is highlighted. Some meters have what is known as a zero adjustment knob. To use this feature, turn the knob until the meter shows 0 ohms. Not all of them have it. Some of the older analog ones have it. Your digital meters may not have a zero, a way of zeroing them out. If you put the leads together and it's reading 0.2 ohms, just take that into consideration when you take your reading. If you really need an accurate reading, put brand new batteries in it. The batteries are starting to get low, and that's why it's reading a resistance when there isn't supposed to be one. Many digital ohm meters are auto-ranging. The correct scale is internally selected. The reading will indicate the range. Most digital meters also have an audible tone when the measured value is very low or at 0. This indicates a closed circuit and is useful when using the meter as a continuity tester. Which determines if a circuit is complete. So continuous, you want the circuit to be continuous. You want to know if it is continuous. If you want to check a light bulb to see if the filament's any good, you can go from the button to the shell of the screw shell on the bulb itself, and you should get continuity. A complete unbroken circuit that can conduct current, this is also called a closed circuit. Okay. Let's just go on. Again, if we skip these parts in your book, you should go over them. You should read them on your own. 1.3.0 ammeter. Remember, amperage is the movement of electrons through a circuit, and this meter will rate or measure the amount of current moving through the circuit. A clamp-on ammeter is also known as a clamp meter. It measures current without touching uninsulated wires. This type of meter works by detecting the strength of the electromagnetic field around the wires. I recommend that if you're getting a meter, you get a clamp-on ammeter multimeter. I would suggest Klein or Fluke. I don't know this Southwire brand. I would look to make sure that it's at least a category 3. Um, it would be category 4 to 600 volts and category 3 to 1,000 volts. Uh, uh, but you want to look for the UL, Underwriters Laboratory, stamp on the back of it. That will tell you if it is sufficient for your needs or not. I don't know that these Southwire meters have a UL rating on them. If it doesn't have a UL rating, there's a reason why it doesn't. Okay. Clamp-on ammeters measure current by using simple transformer principles. Remember that a transformer has a primary and a secondary side. When using an ammeter, the conductor being measured is the primary and the jaws are the secondary. The current of the primary winding creates a current in the secondary winding. If the ratio of the primary winding to the secondary winding is 1,000 to 1, then the secondary current is 1/1000th of the current flowing through the primary. The smaller secondary current is connected to the meter's input. For example, a 1 amp current in the conductor will produce a 1 milliamp current in the meter. Okay. So to measure a current with a clamp-on ammeter, follow these steps. Make sure the jaws of the ammeter are clean and closed tightly. Open the ammeter jaws and close them around the conductors you want to measure. I would say conductor singular. If you go around 2 conductors, if they have a different polarity, they're going to cancel each other out. You can't read across a hot and a neutral, for instance. If you have a receptacle or you have a light and the light is lit up, if you put a clamp-on ammeter around both the hot and the neutral, it'll read 0 because their magnetic fields will cancel each other out. Read the magnitude of the current on the meter displayed. Many meters have a hold function. This is useful in tight locations where the meter is clamped around a conductor, making it hard to read. Just press the hold button when the value is measured, then remove and read the meter. That's a good feature. Caution, when using a clamp-on ammeter, make sure the range of the meter is at least as high as the current you want to measure. If the meter is digital and the current's too high, the display will read OL, open load or overload, over limit. This means that the meter's been overloaded. If the meter is an analog meter, the needle will move beyond the maximum limit of the scale. This might break or damage the meter. Okay. 1.4.0 multimeters. The multimeter is also known as a volt-ohm multimeter or volt-ohm milliamp meter because it measures in the milliamp range. This multi-purpose instrument combines the functions of a voltmeter, an ohm meter, and an ammeter. An analog volt-ohm meter is shown in figure 8. Again, this has an analog needle. If you're going to get a meter, you want to get a digital. They're newer, they're more accurate. Again, look for at least category 3 or 4. I think it's Cat 3 up to 1,000 volts and Cat 4 up to 600 volts. You want to make sure that you're safe. Multimeters are available in analog and digital models. When using an analog multimeter, you're required to select the following: the right voltage, the right function, and the right range. When using a digital multimeter, it's important to select the proper voltage. Most have an auto-ranging feature for the magnitude. So now they're showing us a little bit nicer quality of a meter. I wish I could see what the category is, 3 or 4. But there you go, 119.78 volts. You can't get much closer than that. It's almost 120 volts. It's 119.78. Warning, before you use a multimeter, check it on a known source of electricity. You can use a proving unit for this. Always read and follow the meter manufacturer's instructions. If you don't, you may break the equipment, hurt yourself, or even die. Some multimeters have additional features, including the ability to measure frequency of an AC waveform. This function is useful for finding out harmonic problems in an electrical distribution system. A min-max memory function. It will record the minimum and the maximum readings over a period of time. A capacitance measurement, diode and transistor tester, temperature measurement, true root mean square measurement for accurate voltage and current reading. That's important to get a true RMS meter. When you're buying a meter, try to find one that's true RMS. You'll pay more for it, but they're a much better meter. In addition to the current clamps used with standard multimeters, clamp-on multimeters also are available with test leads. You can use them to measure AC and DC current, AC and DC voltage, resistance, and other values. So here it is with leads. Again, this is that south wire. It's only my opinion. I'm not too crazy about them, but you get this one says true RMS. That's pretty good. It says category 3. I would like to see the back of it. I'd like to see if it has a UL. If it has a UL rating, then there's nothing wrong with this. Okay. 1.5.0 specialty meters. In addition to the more common meters, many special meters are available for taking electrical measurements. Here's the megometer. It measures resistance in the millions of ohms. Megohm. Million ohms. Ordinary ohm meters cannot be used to measure resistance of several million ohms. These higher levels might be found in conductor insulation or between motor or transformer windings. Here's the highlight. To measure these high levels of resistance, you'll need a megometer, also known as a megger or an insulation resistance tester. These meters can be powered by AC, a battery, or a hand crank. So here he's testing the insulation of this metal conductor. He has one lead on the conductor itself and another lead on the metal pipe. He wants to see how much current he can get to flow between this wire and this pipe. And he doesn't want any at all, but we're going to have some stray current or bleed current. So bring it up to 500 volts or 1,000 volts. Some of them go up to, as much as 15,000 volts, but they're not handheld like this. But then they'll measure how much current goes through from the wire itself to the metal pipe. And it should give you a pretty consistent reading as you elevate the voltage. A standard ohm meter uses a small battery in the measurement circuit, typically 1.5 volt. However, a megometer test at much higher voltages, such as 500 volts, 1,000 volts, and even 10,000 volts. For example, in 600 volt class system, applied megometer voltages are usually 500 and 1,000 volts. Using a megometer improperly can result in personal injury or equipment damage. Always read and follow the meter manufacturer's instructions to ensure safe use. Other minimum safety precautions for megometers or megohms use includes the following. High voltages are present when using a megometer. Only qualified individuals may use this test equipment. De-energize and verify the de-energization of the circuit before connecting the meter. If possible, connect the item being checked from other circuit components before using it. Disconnect is what I meant to say. Do not exceed the manufacturer's recommended voltage test levels for the cable or equipment under test. Never touch the test leads when the meter is energized or powered. After the test, discharge any energy that may be left in the circuit by grounding the conductors or equipment for a period equal to the duration of the test. When conducting insulation resistance tests on cables or bus ducts with exposed parts remote from testing position, safely secure or barricade the exposed end to protect others from accidental contact with the test voltage. And like all meters, a megometer is a sensitive instrument. Treat it with care and keep it in its case when not used. Please don't drop it. You can really mess up the calibration on it if you drop it. 1.5.2 Motor and Phase Sequence Indicator. This is a highlight. A motor rotation meter is used to identify the motor legs, while a phase sequence indicator is used to identify the circuit phases. So the meter shown in figure 12 can be used to identify both the legs of a motor and the phase of a circuit. So this is a phase rotation meter. Basically, you have black, red, blue. You put on A, B, C phase. Some of them have black, red, blue, and a neutral or a ground. Regarding static sources such as inverters and PV installations with no moving parts, there's no rotation, only phase sequence. Warning, do not connect a motor rotation tester to energized equipment. If you do, you may hurt yourself or break the equipment. So, to use most motor rotation testers, connect the 3 motor wires to the leads of the tester, then rotate the motor shaft by hand. Give it a little half turn. Indicators on the tester will verify whether the direction of the rotation is clockwise or counterclockwise. If the required rotation is clockwise and the tester also indicates that it's clockwise, tag the motor wires to correspond with the motor rotation leads. If the required rotation is clockwise and the tester indicates the rotation is counterclockwise, switch the leads and retest. Non-contact rotation testers are also available. Phase rotation tester, also known as a phase sequence tester. Make that a highlight. Is used on 3-phase electrical systems to indicate the phase sequence rotation of the voltages. These testers typically have LEDs to indicate the phase rotation. Caution, if 3-phase equipment is connected incorrectly, it can result in equipment damage. Phase rotation tester can be used to ensure correct connection. Warning, phase rotation testers may only be used by qualified individuals. Always wear the appropriate personal protective equipment when approaching energized parts. Okay. A phase rotation tester is used to ensure the same phase rotation throughout a facility. If 3-phase equipment is connected incorrectly, damage can occur. To test phase rotation, de-energize and lock out the power to the circuit, then connect the 3 leads of the tester to the phase conductors of the circuit. Next, safely energize the circuit and observe the meter. Make note of the color scheme of the connected leads to the system, along with the phase sequences as indicated on the meter. This is necessary to ensure the added equipment follows the same phase rotation. So, the leads of a phase rotation tester may not correspond to typical circuit color coding. A good idea is to put the phase tape on the meter leads to correspond to the circuit color coding. This will help ensure correct connections. We go A, B, C, black, red, blue, or if it's high voltage 480 or higher, it's brown, orange, yellow. It's just a rough rule of thumb. 1.5.3 circuit tester. A circuit tester can be used to verify the condition of a grounded circuit. To use the tester, plug it into the grounded outlet. Different lights on the unit indicate various circuit conditions, including an open ground, an open neutral, an open hot, reversed polarity, or a good circuit. And this is what they look like. It plugs into a receptacle, and it tells you if that receptacle is wired correctly. The red is not illuminated, the 2 orange are. It's correct. Irradiance meter. Irradiance meters are used when installing and testing solar photovoltaic systems. Irradiance meters measure the solar radiation energy in a specific place over a specific period of time. So you can leave this, cap it when not in use, but you can leave it out in the light and let it run for 6 hours, 12 hours, and see what the irradiance level is of the sun. And recording instruments, 1.5.5, the current term recording instruments describes instruments that create a permanent record of measured quantities over a period of time. Recording instruments store the information either on a paper strip or in electronic memory. Yeah, nobody uses those paper strips anymore. Back in the 50s and 60s, it was a big deal, and even the 70s and 80s, I've seen some instruments that use a tape or a paper disc, and as it rotates, it will read the level of whatever it's looking for, voltage or current or transients or whatever, and it will make a line, almost like a polygraph test. It'll make a line, a squiggly line on that paper. Now everything's done electronically. It's all, Bluetooth or Wi-Fi. It's all gonna it'll download it right to your computer or your circuit. Those using electronic memory are usually called data loggers. Electrical quantities these instruments record include potential difference, which is voltage, current, power, frequency. Some are also able to record non-electrical quantities. For example, a temperature recorder uses a potentiometer system to record thermocouple output. 1.5.6 remote readout meters. Emerging meter technologies include various types of remote readout meters. Some meters have a removable screen that allow the readings to be taken at a safe distance from the measured circuit or equipment. Other meters pair with smartphone applications that allow the use of Bluetooth meter readings. This feature is especially useful for sharing direct readings with remote engineering or maintenance personnel. So this has a removable meter reading, and the meter still can be clamped on your wires, and you can watch at a safe distance. Meter with detachable display or meter readout using smartphone app. Very good. Section 1.0.0, section review. A voltmeter is used to measure the value of circuits. A closed circuit is indicated by an ohm meter reading of. A meter that can take measurements without touching uninsulated wire is known as what? Current measurements in milliamps are typically read using what? And an expected resistance of 1,000,000 ohms would be measured using what kind of a meter? Very good. So let's go on to the next point.